For each polynomial, factor out the GCF. Make sure the coefficient of the highest degree term is positive after factoring. So if we look at this expression in A, we have negative h plus 10. So you might say, well, there are no common factors. Negative h is negative 1 times h, and 10 is 2 times 5. There's no common factors. But notice that the highest, if we look at the highest degree term, the highest degree term is this first term, this negative h, and in later steps and methods we're going to learn in later sections, we generally want to start with that highest degree term having a positive coefficient. So what we're going to do is purposefully factor out a negative 1. So what I mean by that is I'm going to write negative h as negative 1 times h, and then we have a plus. But now I'm going to think of that negative 10 as negative 1 times something. Well, negative 1 times negative 10 is positive 10, isn't it? So now notice that the GCF, in a sense, is negative 1. And so that means I can write this as negative 1 times h plus negative 10. And what we usually write then is that this is negative quantity h minus 10. Now, if we think about the distributive property, and what we learned in previous sections, the distributive property would tell us, if we wanted to go backwards to check our work now, we would have a negative h and a negative negative 10, a negative h plus 10. So that checks out. All right. All right, exercise B, we have negative h minus 10. So now notice these do have a factor of negative 1. Right? Negative h is negative 1 times h. Negative 10 is negative 1 times 2 times 5. And we do have a common factor of negative 1. So I can think of this as negative 1 times h plus negative 1 times positive 10. So, factoring out that common factor of negative 1, I can write this as negative 1 times h plus 10, or more simply, negative quantity h plus 10. Now look at the third expression. We have h minus 10. There are no factors in common here. H is simply h, and negative 10 I can think of as I did before, negative 1 times 2 times 5. There are no common factors here. The highest degree term is already positive, so I'm going to leave it as it is, h minus 10. In exercise D, we have negative 2h plus 10. So the GCF is 2. But I'm going to purposefully factor out a negative 2. Again, because if we look at the highest degree term, it has that negative, and we want it to be positive after we factor, so I'm going to purposefully factor out the negative 2. So I have negative 2 times h plus negative 2 times negative 5. So I can write that as negative 2 times h plus negative 5, or more simply, negative 2 by the quantity h minus 5. And that is the factored form that we want.